Alright, so today we're looking at equations and inequalities. So our learning intention is the knowledge of using transformations or dilations of functions to help assist us in solving equations. So we're going to be successful if we can correctly transform and dilate functions as required, and then if we can use these graphs to solve equations and solve inequalities. And when we're talking about solving inequalities, we're talking about the regions where solutions are true. So let's do some examples. First example says, for each function f of x, we want to state how many solutions there are. So solutions means how many x-intercepts. Alright, that's what it's actually asking us. How many times does the function cross the x-axis? So here's our first example. As you can tell, I've got a cross there, I've got a cross here, and across here. So technically there are 3 solutions to this function. Here I only have 1. And here I actually only have 1 as well. I do have 2 asymptotes, so I'm basically I'm going to have 1 critical value, which is the horizontal asymptote. And I will also have 1 vertical asymptote, sorry. So that should be vertical. We'll have 1 horizontal asymptote. As well, but that's a restriction. So when we look for how many solutions, that's what we're asking for. How many times it cuts the x-axis. So we want to sketch the function y equals 3 absolute of x minus 2 plus 4. Alright. So we know that the parent graph is y equals so I'll just write it down here. So the parent graph is what the absolute of x. It's got a horizontal translation. And this is going to be to the right by 2 units. And that's going to give us that one. I then have a vertical dilation, which will make the graph narrower or a stretch. And then I vertically translate it up of 4 units. So knowing my graphs, when it says how many solutions does this have, so if it had that equal to 0, right, let me try, that would be, let's do that. Well then, because I've translated it up and I know I start at the origin, there'll be no solutions. I'll just show you my graph. Alright, so there I start with my absolute of x. I shift it 2 units so that this 0, 0 becomes now 2, 0. Yep. I then have a dilation of 3, so all points were multiplied by 3 units, and then it got translated to 4. So here I get 2, 4. If I use the graph for how many solutions does this function equal 1? So that means that when when the y equals 1. Okay, so using my final graph, Yeah, there's 1. Well, the graph doesn't touch it. So this would also be no solutions. The first solution would be when equals 4. Yeah, which will be this point here. Okay. So solve graphically. When does this function equal 10? And we want to check our answers algebraically. So let's do the algebra first, and then I'll use the graph. All right. So if I, I'll get rid of the 4 first by taking it to the other side. So that becomes 6, and then I'll divide by 3. Okay. So what happens here is now I have 2 possible scenarios. I have the positive scenario, so x minus 2 equals 3. Okay, so bring that 2 across, that's x over 5. Then I've also got the negative scenario. So where x minus 2 is equal to negative 3. Okay. So add 2, so I'll get 2 solutions, x equals to 5 and x equals negative 1. So let's use that, let's look at our graph and see what we get. Alright, so here is our function. But this image is actually not correct. Alright, as I noticed where my mistake was. So looking at this, so 3 divided by 6 is actually 2, not 3. Okay, we still have the positive solution. So that would be 4. That's going to be 2. So that's going to be 0. Okay, now using our graph, okay, so this is y equals 3 lots of x minus 2 absolute plus 4. Alright, when it equals 10, I'm looking at these 2 points here. Yep, so it happens at 0 and at 4. And that's where you get the solution from. Alright, let's do this one. We want to solve when 3x plus 4, let's say, is greater than or equal to 13. Alright, so let's do it algebraically first. So we still get x minus 2, I'll bring the 4 across, so that's going to be 9, by subtracting 4 to both sides, then divide by 3, and that gives us 3. Okay, so same thing, we're going to get 2 possible solutions. Okay, the positive solution, so x minus 2 is greater than 3, so we get x, plus 2 is 5, yep. And then we're going to also get the negative solution. So x minus 2 and we want to get the negative solution. Okay, so notice that I flip the sign when I want my negative solution. Alright, so now I get minus 3 minus 2. No, minus 3 plus 2 becomes minus 1. Okay, so I'm going to get the solution where, so finally, it's going to be x is less than or equal to -1, or x is greater than or equal to 5. So let's look at the graph though. So when does this function is greater than 13? So that's 13 here. So 10, 11, 12, 13. Okay. So I'm looking at this point and this point, and this area here is above the graph, and this area here is above the graph. So that relates to -1 and 5. Yeah, so the function is less than -1, or when x is greater than 5. Okay. Let us do some more. Alright, so this is how I translated it. So I think I should explain that. That's all the functions all together. So we moved y equals absolute of x, we moved it across to x minus 2. Then we dilated it, and then we translated it. Alright, we want to draw the graph y equals to x minus 3 plus 5 to solve. So this is a linear function, so that's y equals x. I translate it to the right by 3 units. So I translate it, to the right by 3 units. There's my little graph. I then had a dilation of 2, and then I translated it up by 5 units. So my red line is my final function. Okay. When is this function less than 7? So algebraically, we can, we've got so 4. Yep. So this function is less than 7 when x equals 4. So here's my 7. I hit the line. Yep. And the line is less than 7 when x is less than 4. So it's all this area. Alright, let's do this algebraically for this one. We want to know when it's greater than 9. So logically it's going to be bigger than 4, but let's just check. So I'm going to take away 4. So take away 5 to both sides. And then we're going to add 3. So it's when x is greater than 5. So there's 7, 8, 9. If I come down, So if x is bigger than 5, then the line is above the y coordinates of 9. Okay, so when is the function, or when does the line equal to 4? Okay, algebraically, it will work out when x equals 2.5. But if I look at my graph, 1, 2, 3, 4, hit my line, I don't actually hit another grid line, so it's approximately between 2 and 3. So I said around about, so approximately graphically, it's 2.5. Okay, so graphically, because I don't actually have the line sitting anywhere, I would say x is approximately 2.5. But we solved it algebraically that it was 2.5. Okay, thank you very much.